Guys, can you see me and hear me? Just let me know, everyone. So today is, you can say, the first session for ray optics. So just let me know if everyone can hear me and see me. Then we'll start with our session, right? Okay, good. So how's everyone? Go ahead. Just write something in the chat so that I can see you guys. Meghna is there. Good evening, Meghna. How are you, beta? How's your day? Okay. Okay. Meghna, can you hear me and see me, beta? Just let me know. Yes, I'm waiting for it, right? Fine, it is. So, Meghna, I can see you only. So let's start with the first question, that is from prism, right? So a thin prism having a refractive, you can say refractive angle 10 degree, is made of glass of refractive index 1.42. This prism is combined with another thin prism of glass of refractive index 1.7, 1.42, 10 degrees. Simple question. This combination produces dispersion without deviation, right? So the refractive, or you can say refracting angle of second prism should be. So Avanish, Aditya, and Meghna, do you guys have any idea how to do this one? This is like dispersion without deviation. I taught you, right? Muhammad Shamim, how are you, beta? So, good evening. Good evening, Aditi Chaurasia. So, any idea about this question? Is there anyone who can do this one? Let me know, everyone. Good afternoon, Abhishek. Yeah. So, any idea or no idea? Okay, I'll just tell you, because this is based on a simple formula, like a formula for dispersion without deviation. So I'll write the formula and will then ask. Anjali, you are back. Saurav is there. Good, Anjali. So mu minus 1 into A1. So mu1 minus 1 into A1 plus mu2 minus 1 into A2 should be 0. This is the condition for dispersion without deviation. Okay, Kaplish says B. Let's see. So dispersion without deviation, the condition is mu minus 1 into A1 plus mu2 minus 1 into A2. Dharmik is asking me to explain again. Dharmik, okay, so this is without deviation, right? So deviation by prism 1 plus deviation by prism 2 should be 0, right? And you know what is deviation? Delta is equals to mu minus 1 into A. Dharmik, I'm not doing anything rocket science over here. It's a simple one, right? So dispersion by first prism is here. Dispersion by second prism is here. So net deviation should be 0. So this is 0, right? So deviation by first prism plus deviation by second prism is equals to 0. Now you just need to put the values in this one, right? So it should be like mu1 is given as 1.42 minus 1 into 10 degrees is equals to mu2, which is 7 minus 1 into A2. Now you just need to find A2 and we are done with it. We are done. Yes, Meghna. So it is 0.42 into 10 by 0.7. And I can see that this will come out to be 6 degrees. So how many of you are fine with that? I'll just write it. First, I will change the color, right? So A2, it is A2, not A square. That is the angle of the second prism. It is 6 degrees. So how many of you are fine with that? Saurav is there, Arsalan is there. You guys are fine with this question? So the option, correct option, good. So many kids were saying B, and that is correct. Very good. So is there anyone who is having a doubt in this one? You just need to add the deviations produced by the first prism and the second prism, right? Let's move to the next one. Let's see how many of you can do this one. This is pretty easy. Question number 2 for the day. Go ahead. Anjali, what do you say about the second question? The ratio of resolving powers of an optical microscope for two wavelengths